Hello students. So here again one more class on permutations and combinations. We'll discuss today new concept we have done in the previous classes, geometry related problems, right? So now today we'll see one more application of permutation combinations in number theory, right? Some questions are find number of divisors, find the number of even divisors, number of odd divisors. So such type of questions we are going to see the concept of that. Let's say we have a number, say 360. Okay, now if you split this 360 as product of primes, you can get this. Okay, you can write yourself this one, 360 as 2 cube into 3 square into 5, correct? 2 cube is 8 and 8 nines are 72 into 5. If you see that 5 2s are 10 and 5 7 35, so 360. So this is called actually canonical form of a number. Canonical form means you have to write the given number as product of only primes. We should see only primes in the number. Okay, 360 as a product of primes 2 3 5. Okay, so first of all you have to write the canonical form of a number. Canonical form means what? Once again I repeat, writing as product of primes. Okay, if you write as product of primes, that will become canonical form of a number, right? Now here we have to find out how many divisors are there for 360. So if you want to write the divisors of 360, okay, manually we have to write all the numbers, how many are there. For example, 1 is a divisor of 360, 2 is also a divisor of 360, 3 is also a divisor of 360, 3 to the 6 is also, 4 is also a divisor, 8 is also a divisor, 5 is also a divisor. So you have to write all the divisors of 360 and then you have to count, right? So that is the thing we do manually. Each and every divisor you have to see and you have to write, then you have to count. So instead of doing like this, we have direct formula to find out number of divisors. Now once we will see how we got that formula, okay, then first we will see the formula concept, that we'll use that formula to find out number of divisors. Now let's say for example here 2 cube means here we have 3 2's, right? 3 square means you have 2 3's and 1 5, you have 3 2's, 2 3's and 1 5 you have. So now here we are going to deal this problem with the using permutations and combinations concept. Okay, selections, using selections we are going to solve this problem. Let's say here we have 2 2 2, right, and then we have 3 3 and one more 5 we have. Now you suppose that these are 3 identical balls, 3 identical yellow balls. Okay, now here we have 2 identical red balls. Okay, 2 identical red balls, and you have at the end one blue ball. So instead of saying you have 2 2 2 and here we have 3 and here we have 5. So instead of saying in terms of numbers, say in terms of balls. Okay, we are going to convert this using a problem of permutations and combinations. Okay, now how to think of, let us suppose you have 3 yellow identical balls, 3 identical balls of yellow color and 2 identical balls of red color, 2 identical balls of red color and one single ball of blue color. Okay, now what I'm going to do, let's see here, we'll take different type of combinations from these balls. Now I am not going to suppose any number here. Let's say 3 yellow colored identical balls, 2 red colored identical balls and one blue ball you have. Now let's say what I do, I'll select one yellow ball. Okay, if I select one yellow ball means I selected the 2. So therefore one divisor is going to be 2. Yes or no? The divisor is going to be what? 2. So one of the divisors of 360 is nothing but a combination, is a selection, right? One yellow ball is I am selecting, then I got a divisor. Let's suppose now the second thing, what I did here, one yellow ball and one red ball. If I select one yellow ball and one red ball, it corresponds to a divisor. What is that? Can you guess? 2 into 3 is 6. So 6 is a divisor. So what is the meaning of this? If we have one combination, if we have one combination of these balls, if we have one combination, means you are getting one divisor. You are getting what? One divisor. Now here I have a second combination. What is it? A combination of two balls. One is yellow and one is red. So I got 6. 2 into 3. I got 6. So one more divisor. So I got here two combinations. One combination, two combination. So for two combination, I got two divisors also. What is the meaning of this? Each combination is giving you one divisor. So I got two combinations here. So I got two divisors. So what is the meaning of this? What is the meaning of this? One combination gives one divisor, means how many combinations are there? The question comes, how many combinations are there? How many combinations are there? Means using three identical yellow balls, two identical red balls, one different blue ball, using these six balls totally, using these six balls, how many combinations can be made? What is the meaning of combination? Nothing but selections. So total number of selections. For example, let's say one more combination here. I selected two red balls, right? Two red balls and one blue ball. So this gives us one more divisor. You know what is that divisor? Can you guess? 3 3 is 9, 9 5 is 45. So 45 is one more divisor. So you can understand from this that whenever you have a combination, you have a divisor. Whenever you have a combination, you have a divisor. So therefore, how many divisors are there? If I ask you a question, how many divisors are there for 360? How many divisors are there means indirectly we are asking about how many combinations are there. We are asking that how many combinations are there of these six balls. So how many combination means indirectly we are asking how many selections are there. How many selections are there? So how many selections are there? That many combinations are there. How many combinations are there? That many divisors are there. So now the final question is what? How many ways you can select balls? So total number of selections. So here we have total number of selections. The question is actually total number of selections, right? Now we know the total number of selections of identical balls already we have learnt in the previous lessons, right? If you didn't see that, you can go and check that videos to understand the number of selections of identical objects. Okay, so now you see here we have three identical balls. How many ways you can select identical balls? So here you can select zero identical ball from yellow, right? You can select one yellow ball, or you can select two yellow balls, or you can select three yellow balls. So total number of selections are how many? Four ways. Four ways you can select yellow balls. Okay, now here you should not think like this. If you want to select two balls, you should not say from 3 we want to 2, so 3 see two ways. This is wrong because of they are identical. They are identical. So if you want to select two balls, that can be done in only one way. You can't say like this. So we will selected first ball and second ball one way. You select second ball and third ball one more way. This is wrong because if you select the first and second, you get the same two yellow, and if you select second and there is also same selection. Okay, there is also same selection. They are not different selections. So therefore, if you want to select one yellow ball, it can be done in only one way. From these three yellow balls, if you want one ball, it can be done in only one way. So therefore, selection of one ball is in one way, selection of two balls is in one way, selection of three balls in one way. So totally we have four ways. So how many combinations are there with yellow balls is four ways. Now how many combinations are there with red balls is how many? Zero red balls, one red ball, two red ball. Means it can be selected in how many ways? Three ways. And for these five, it can be selected or it cannot be. Means zero blue ball or one blue ball, so it can be selected in two ways. Now you see number of balls here 3, but number of ways of selection is 4, means 3 plus 1. Why this one is coming extra? Because of 0 balls also included in the selection. Okay, so here we have 2 red balls, so 2 plus 1 ways. Okay, and here 1 blue ball, that is 1 plus 1. So can you see this 3 plus 1 is, how many 2's are there? 3. So 3 plus 1. How many 3's are there? 2. So 2 plus 1. How many 5's are there? 1. So 1 plus 1. Okay, so the power of the each prime plus 1, power of each prime. So the power of 2 is 3. So 3 plus 1. Power of 3 is 2. Therefore 2 plus 1. And power of 5 is 1. So 1 plus 1. Now here total number of combination means, according to fundamental principle of multiplication, 3 plus 1 into 2 plus 1 into 1 plus 1. So once again I repeat, once you concentrate here. So how many total number of how many combinations are there? Total number of combinations you have to find out, that gives you number of divisors. So initially I explained number of divisors, nothing but number of combinations. Number of combinations means total number of selections. So total number of selection means how many ways you can select 2's, how many ways you can select 3's, how many ways you can select 5's, how many ways you can select 2's, means that can be done in 3 plus 1 way, and how many ways you can select 3's, that can be done in 2 plus 1 way, and how many ways you can select 5 power 1, means 1 plus 1 ways. Okay, so total number of combinations is, you have to multiply them, which is 4 into 3 into 2, which is equal to 4 3 is 12, 12 to the 24. So total number of divisors are how many? 24. The total number of divisors is 24. So can we formulate this now? Okay, let's suppose you have a number n, you have a number n which can be written as a canonical form, like say p1 to the power of alpha 1, p1 is a prime, p2 to the power of alpha 2, p3 to the power of alpha 3, up to so on pr to the power of alpha r. Suppose you have given a number n and we are writing canonical form of that using the primes, right? Whenever you write product of primes as a power of primes, product of power of primes, that is called a canonical form. So first you must write the canonical form of a given number. Okay, p1 to the power of alpha 1, p2 to the power of alpha 2, p3 to the power of alpha 3, up to so on pr to the power of alpha r. Then the number of divisors of n, the question is, if I ask you the number of divisors of n. So if you want to find out number of divisors of n, is nothing but the total number of selections, the total number of combinations. Okay, we want to find out what? The total number of combinations. How to think this? How to think about this? Total number of combination means here p1, okay, is a prime. You can think of a ball of a color, let's like yellow ball. Okay, how many are there? Alpha 1. So total number of selections will be what? Alpha 1 plus 1. Okay, like I explained in the previous example with this. So alpha 1 plus 1 for p1, and for p2 what you write? Alpha 2 plus 1, and for p3 what you write? Alpha 3 plus 1. So up to so on alpha r plus 1. Simple. For every power of prime you have to add 1. Power of prime is how much here? Alpha 1. So you add 1. Alpha 2 plus 1. Alpha 3 plus 1. So up to so on alpha r plus 1. This product gives you the number of divisors of n. Okay. Now let's see. One simple thing in this. For example, you want to find out number of divisors. Now you know how to find, right? Number of divisors, if you want, it is easy, right? 3 plus 1, 2 plus 1 into 1 plus 1, right? So that gives you the number of divisors. Now let's say I want number of even divisors. Number of even divisors. Number of even divisors. Now let's see. Whenever you want even divisor, 2 must be present in your combination. Correct? Because of, you see, whenever you have 2 in your combination, it will become a 2 multiple. It will become a 2 multiple. Because of each combination we are multiplying. This is a one combination. What we are doing to get the divisor? 2 into 3 we are doing. So if 2 is present, automatically the divisor will become a multiple of 2. If it is a multiple of 2, automatically it will become even divisor. Do you understand? Okay. It will become even divisor if at least one yellow ball should be there. Yellow ball means nothing but a 2. 1 2 should be there in your combination. 1 2 should be there in your selection. Then that will become a multiple of 2. That will become even divisor. So if you want to get how many even divisors are there, means indirectly how many even divisors means how many combinations are there or how many selections are there. The question is, equivalent question is, how many selections are there in which at least 1 2 must be there. At least 1 2 should present. 1 2 must be there, must be included. At least 1 2 must be included to get even divisor. Okay, now previously what we have done, whenever you want total number of combinations, if you are thinking about this yellow balls, what are the combinations we are thinking? 0 yellow ball in our selection, 1 yellow ball, 2 yellow ball and 3 yellow balls. These are the ways. We are saying 4 ways, right? That nothing but we are writing 3 plus 1. What is this one specially? That is corresponding to 0. No yellow ball is this one. 1 yellow ball, 2 yellow balls, 3 yellow ball. There is 3 way obviously, but one more way extra. Why we are getting? Because we are considering 0 yellow balls. Now here we want at least 1 2. What do we want? 1 2 must be included. Therefore this selection 0 balls is gone now. So we'll have at least one ball means maybe one yellow ball, maybe two yellow balls, maybe three yellow balls. Therefore now the number of ways of selecting yellow balls will be, combinations will be only three ways. Because of 0 yellow ball we are not going to consider, because of we want minimum one yellow ball in the combination. At least one yellow ball in the combination means at least 1 2 we want in the combination, so that it will become a multiple of 2, so that it will become even divisor. I hope you understood this point, right? So whenever you want to find out number of even divisors, whenever you want to find out number of even divisor, what we must include? We must include at least 1 2. So therefore corresponding to how many selections are there? Now you tell me, corresponding to at least 1 2 we want. So out of 0 ball, 1 ball, 2 ball, 3 ball, 4 ways. Now we are not going to take this one, so there are only 3 ways for 2. And for 3 obviously 3 ways again, because of 2 plus 1 and 5 we have 1 plus 1, so which is equal to 3 3 is 9 into 2, which is 18. So totally we have 18 even divisors. Okay, we got the even divisors, number of even divisors answer, right? Now next thing is, how many odd divisors are there? If I ask you the question, number of odd divisors, if I ask you the question, how many odd divisors are there? So it can be done in two ways. One is total number of divisors minus number of even divisors. Total number of divisors minus number of even divisors. If you do, obviously you are going to get number of odd divisors. Or otherwise, if you want odd divisor, what is the meaning of this? 2 should not be present in the combination. If 2 is present, automatically it will become even divisor. So if you want odd divisors, no 2 should be present in the combination. If no 2 should be present in the combination, you will get number of odd divisors. Okay, I hope clear this point, how to find out number of divisors, number of even divisors, number of odd divisors. Let's see with an example, so that if you have any doubts, it is going to be clear now, right? Now let's see. So here we have n is equal to 2160. N is equals to 2160. What is the question? Now you see the question is this: the number of divisors of n we have to find out. The number of divisors of n we have to find out. The second question is the number of even divisors of n. What we have learned just now, what we observed just now, one problem we are going to do on that, so that it will be clear for you, right? So the third question is the number of odd divisors of n. So number of divisors, number of even divisors, as well as number of odd divisors. Now you see n is equals to 2160. So to find out the answer for these questions, you need to write first canonical form. So this I will write as 216 into 10. Okay, and I think 216 is 6 cube, right, into 2 into 5, and you know this you can write as 2 into 3, so 2 cube into 3 cube into 2 into 5. So the final canonical form of n is 2 to the power of 4, 2 cube into 2 to the power of 4 into 3 to the power of 3 into 5 to the power of 1. Okay, so this is the canonical form. Okay, we should see only primes in the product, that is called canonical form. So after writing the canonical form, now the question is how many divisors are there. So the first question, the number of divisors of n, the number of divisors the number of divisors of n is equal to, simply what we do, alpha 1, this is alpha 2, this is alpha 3, powers of the primes. So alpha 1 plus 1, that is 4 plus 1, into alpha 2 plus 1, that is 3 plus 1, and alpha 3 plus 1, that is 1 plus 1. So which is equal to 5 into 4 into 2, which is equal to 5 4 is a 20, 22 is a 40, right? So the number of divisors of n is how much? 40. Now let's see the second question. Okay, this is very simple questions, basic questions. We'll do some little advanced questions in the next video lesson. So keep in touch with the channel, right? So the number of divisors of n, we got 40. Now we want the number of even divisors of n. So even divisors of n means what? At least 1, 2 must be included. So at least 1, 2 must be included means how many ways you can select these twos? How many combinations are there with the twos? 1, 2, 2 twos, 3 twos, and 4 twos, means 4 ways. But what you are writing here, I am repeating that, okay, to make you understand. I am repeating the same explanation. Here you see we have 4 ways. Selection of these 4 twos can be done in how many ways? 4 ways. We are not taking 5 ways, but here I took 5 ways. What is that? 0 twos, right? So here it is included, but we want at least 1 2 in the combination so that it will become a multiple of 2. Okay, so therefore how many ways you can select twos? How many combinations are there with twos? Means only 4 combinations. So therefore the number of even divisors of n is what? So how many ways you can select twos? 4 ways, into 3's are 3 plus 1 again. So for 3 there is no problem, right? And for 5 we have 1 plus 1 way. Okay, just whenever you want even divisors, this one you have to skip. Instead of this 4 plus 1, just you have to take only 4. So power of 2, whatever the number you are seeing, as it is you have to take, no plus 1, right? So this gives you 4 into 2. So 4 for the 16 to the 32. So total number of even divisors is 32. Total number of even divisors is 32. Now the third question is what? The number of odd divisors. The number of odd divisors of n. The number of odd divisors of n. What is the number of odd divisors of n? Total number of divisors, how many? 40. So from 40, if you subtract even divisors 32, obviously you will get odd divisors. Total number of divisors 40, but among which 32 divisors are even divisors. So the remaining are what? Odd divisors. Therefore 8 odd divisors are there. But alternatively, if you want to do in a different way, that also can be done. How? Whenever you want odd divisors, no 2 should be present in the combination. Okay, if 2 is not included in the combination, it will not be a multiple of 2. If it is not a multiple of 2, it will become odd divisors. Means how many ways you can select 2's? Only one way, because of 0 2's we want. Okay, we cannot take 1 2, or we cannot take 2 2's, 3 2's. For these 4 choices will be gone for our divisors, because of we don't want any 2 in our combination. So we have only one choice, 0 2's. So therefore for our divisor, alternatively what we can do, how many ways you can select this 2's? One way, because of 0 2's. And how many ways you can select 3's? 3 plus 1. Now we can write 3 plus 1 into how many ways you can select 5's? 1 plus 1. There is no restriction on 3 and 5, only restriction on 2 to get odd divisors. So this is what? 1 into 4 into 2, which is equal to 8. So number of odd divisors is 8. You can see here we got in a different way. The total number of divisors minus even divisors is 8, or directly you can calculate without 2. Means 0 2s is one way, and 3 plus 1, 1 plus 1, which gives you 8. So the number of odd divisors of n. Okay, so in the next class we'll see little bit twisted questions on the same concept. Thank you for watching. If you like the video, subscribe to my channel.